Can time run differently at your feet and your head? Thanks to relativity, your head actually ages faster than your toes by a tiny fraction of a second. Hey everyone, and welcome back to the channel where we tackle some seriously mind-bending ideas that might just change how you think about the world around you. Have you ever noticed how you sometimes feel like time is dragging on when you are bored but seems to fly by when you're having a blast? It's a strangely subjective experience, isn't it? And it makes you wonder if there is actually something fundamental about our perception of time itself that we don't fully understand. Today, we are diving into a truly fascinating concept that comes straight out of Einstein's theory of relativity, and it suggests that time doesn't necessarily take at the same rate for every part of your body. Specifically, scientists have discovered that your head and your feet experience time slightly differently, with your head actually aging by a tiny, measurable fraction of a second compared to your toes. This isn't some science fiction plot, this is a verified experimental observation, and it's a direct consequence of the fact that time is relative, not absolute, as Newton once believed. Now, before you start worrying about your feet turning into ancient artifacts while your brain remains eternally youthful, let's break down exactly how this works and why it's such a remarkable discovery. Einstein's theory of special relativity, published in 1905, fundamentally altered our understanding of space and time, demonstrating that they're intertwined into a single entity called space-time. According to this theory, the faster you move through space, the slower you move through time, and this effect is incredibly subtle at everyday speeds. But it becomes significant as you approach the speed of light. Imagine a clock on a spaceship traveling at a very high velocity. The clock on the spaceship will tick slower than an identical clock that remains stationary on Earth. This isn't a trick of the clock, it's a genuine difference in the passage of time, and this difference is directly related to your relative speed through space-time. So how does this relate to your feet and your head? Well, the key is the movement of your body, particularly the movement of your head. When you move, your head is effectively experiencing a different frame of reference compared to the rest of your body, and this difference in movement creates a slight variation in the rate at which time passes for each. Researchers at the University of Glasgow conducted a pioneering experiment in 2010 that provided compelling evidence for this phenomenon, and their findings were published in the journal Applied Physics Letters. They used an atomic clock, an incredibly precise timepiece, to measure the time dilation experienced by subjects who were asked to move their heads in different directions while the clock recorded the data. In the experiment, participants were asked to move their heads horizontally, vertically, and diagonally, and the atomic clock detected a measurable difference in the time recorded by the head and the feet. Specifically, the head experienced a tiny but statistically significant delay relative to the feet, indicating that time was flowing slightly slower for the head during the movement. The effect was most pronounced when the participants moved their heads diagonally, suggesting that the combination of horizontal and vertical movement created the greatest difference in space-time experience. The difference in time experience was incredibly small, on the order of a few microseconds per second, but it was undeniably there, and it was consistently observed across multiple experiments. Now you might be thinking, okay, this is cool, but why does this happen and what does it all mean? The underlying reason lies in the fact that when you move your head, your brain is processing information and making adjustments, and this requires energy which impacts the local spacetime environment. Essentially, the act of movement creates a tiny distortion in spacetime, and this distortion affects the passage of time for different parts of your body differently. It is like a ripple in a pond, the disturbance spreads outwards, and the effects are felt differently depending on your proximity to the source of the disturbance. This doesn't mean that your head is somehow more or less time than your feet. It simply means that the interaction between your movement and the fabric of space-time creates a measurable difference in the rate at which time passes. It is crucial to understand that this isn't about aging faster or slower, it's about the fundamental nature of space and time, and how they are intertwined and affected by motion. This discovery has profound implications for our understanding of the universe, and it reinforces the idea that our perception of reality is often shaped by our relative motion. Furthermore, research into this effect is ongoing, and scientists are exploring ways to utilize it in technologies like ultra precise navigation systems and even quantum computing. Imagine a GPS system that can account for the minuscule time differences experienced by different parts of the satellite, leading to vastly improved accuracy. So the next time you're walking, running, or simply moving your head, remember that you're not just experiencing movement, you're also interacting with the very fabric of space-time. It's a testament to the brilliance of Einstein's theory and a reminder that the universe is far stranger and more wonderful than we often realize. Ultimately, this fascinating experiment highlights the fact that our everyday experiences are governed by laws of physics that are both beautiful and profoundly counterintuitive. What do you think about this discovery, and how does it change your perspective on time and space? Let us know your thoughts in the comments below, and don't forget to like and subscribe for more explorations into the fascinating world of science and technology. Thanks for watching, and we'll see you in the next video.